Sometimes, the biggest mysteries begin with something so small you almost miss it. A number. A tiny drop in a line. A moment where the universe seems to stutter and then pretend nothing happened. That's exactly what happened with 3I/Atlas. For months, astronomers all around the world watched this wandering object drift toward the sun. It wasn't special at first. It wasn't dramatic or threatening. Just another interstellar visitor passing through our system, the way a stranger might walk through a quiet town and keep moving. Everything about it looked normal, predictable, almost boring. Its orbit was clean. Its brightness followed the same pattern every comet does when it gets closer to heat. And scientists waited for that simple, expected rise. The moment every comet begins to glow brighter as it nears the sun. But then, the universe blinked, and everything changed. It happened in a single moment on a quiet night, one of those nights where the world feels still and the sky feels endless. A research team stared at the new data coming in, numbers forming soft curves on a screen. The light curve should have gone up. Everyone knew that. It had to go up. But instead, it dropped. Not by much. Not enough for panic. At least not at first. Just a little dip, a tiny step backward. Like the object took a breath and hesitated. At first, the team tried to explain it away. Maybe it was a software glitch. Maybe the telescope shook. Maybe some stray cosmic dust passed in front of the lens. There were 100 small excuses that made more sense than the truth. No one wanted to consider. But the data didn't glitch. The equipment didn't fail. And the dip didn't correct itself. It stayed there. A scar in the light curve. A mark that shouldn't exist. One of the younger astronomers leaned closer to the screen, squinting at the line like it was some kind of illusion. "That shouldn't be possible," she whispered. "Because comets don't dim when they get closer to the sun. They brighten. They always brighten." So the room fell quiet, the kind of silence that makes your skin tense, because you can feel something shifting, but you don't know what. The team ran the numbers again and again and again. No change. The universe had given them a dip where there should have been a rise. A contradiction wrapped inside a single pixel on a screen. Hours passed. More telescopes joined in. Data came from Europe, then South America, then Asia. Different systems, different nights, different angles, same glitch. And that's when the mood changed, because one mistake is fine. 2 mistakes might still be noise, but when every major observatory on Earth sees the same impossible drop, even the most skeptical scientist feels a cold wave crawl up their spine. Something was wrong, very wrong. But here's the strange part. The dip didn't feel random. It didn't look messy or chaotic. It wasn't the kind of error nature makes when it's being wild or unpredictable. The drop was clean, sharp, almost precise. Too precise. Like someone had reached out and pushed the brightness down, on purpose. That was the thought no one said out loud. Not yet. Not in the early hours of the discovery. Instead, they used softer words: anomaly, irregularity, unexpected behavior. But the feeling in the room told the real story. It felt engineered. A few researchers laughed nervously at the idea, because if you say it plainly, it sounds impossible. It sounds like science fiction. A comet adjusting its brightness, a rock from another star system acting with intention. That wasn't even a theory worth publishing, at least not yet. By morning, the news had spread through the astronomical community. Private message boards lit up. Late-night emails flew back and forth. Scientists stared at the graphs on their screens, rubbing tired eyes, wondering if they were all looking at the same impossible thing. A comet that dimmed when it should brighten. A drop timed so perfectly it almost looked deliberate. But science is cautious. You don't jump to wild ideas. You don't talk about purpose or design, not when you're dealing with the sky. So they searched for other answers. Solar interference, instrument noise, a calibration flaw, atmospheric scatter. Every simple explanation was tested. Every logical path followed. And every single one failed. The dip remained, unshaken, untouched by anything they tried to blame it on. Hours became days, and the small glitch that started as a footnote became the center of every conversation. The more they stared at it, the stranger it felt. It was like 3IATLAS was trying to hide something, or trying to reveal it. No one knew which. But they knew this. Nature doesn't make clean mistakes. It doesn't dim with mathematical precision. It doesn't pause in a way that feels so intentional. And slowly, the fear crept in. What if this wasn't a mistake? What if the curve wasn't slipping, but signaling? One researcher wrote a note in her private log, a sentence she didn't dare say out loud. If this pattern repeats, we're not looking at a comet anymore. Because a comet is predictable. A comet follows rules. A comet behaves like ice and rock and dust, not like something alive or something built. So the world watched the object move deeper into the inner system. Every night became a test. Every new reading felt like a breath being held. Would the curve rise again? Would it fall? Or would it reveal something worse? And then, on the third night after the anomaly, an observatory in Chile captured something that made the entire scientific community freeze. A second dip, almost identical to the first, at the exact same relative moment in the object's motion. Same shape, same depth, same precision. It wasn't a glitch anymore. It was a pattern. And patterns don't happen by accident. A quiet panic spread through teams around the world. Theories whispered like shadows. Eyes grew tired from staring at screens, hoping for clarity but finding only deeper confusion. Something about 3I/Atlas was behaving with purpose. The object wasn't just reacting to sunlight. It wasn't following the rules of thermal physics. It was doing something else, something no one had words for yet. And as the object drifted closer toward Perihelion, closer to the moment of truth, one haunting question echoed through every lab, every think tank, every sleepless mind watching. What kind of visitor dims its own light right before entering the fire? Because if the first glitch was a whisper, this second one felt like a message. A warning, a signal. A quiet voice from the dark saying, "Watch closely." And the world did, not knowing the next chapter would make the first glitch look almost harmless. Sometimes the universe speaks in flashes, tiny blinks of light across a black sky, almost like a heartbeat. But what happens when that heartbeat repeats? What happens when it doesn't drift or fade, but lands in the exact same place again and again? That was the moment scientists realized 3I/Atlas wasn't just acting strange. It was keeping time. It started quietly. A few observatories scattered around the world noticed something odd in the brightness readings. At first it looked messy, the kind of noise you see when equipment gets tired. or when the night air shakes just a little too much. A spike here, a small flash there, nothing you would call important. But then, a research assistant in Australia did something simple, something everyone else missed. She zoomed in, and the noise wasn't noise anymore. She saw a pulse, a tiny rise in brightness that appeared like a soft blink, barely noticeable, barely different from background static. But it was there. So she checked the next night's data, and the night after that, and slowly, the pulse began to stack, one on top of another, almost like footsteps echoing through a long hallway. The team held their breath. Because stars flicker, planets reflect, comets glow in bursts. But this was none of that. The pulse repeated every 12 seconds. Not 11, not 13. 12. Perfect. Clean. Unchanging. As if someone had set a timer and pressed start. Soon, observatories in Chile, Japan, and South Africa confirmed the same thing. The same soft blink, rising out of the darkness every 12 seconds, like the tick of an invisible clock. Scientists stared at their screens in disbelief. Nothing in the natural universe keeps time like that. Not with perfect rhythm. Not across distance, motion, temperature, and dust. A comet is chaos, a wandering rock that spins and breaks and sputters. It doesn't pulse like a metronome. It doesn't whisper in steady beats. Yet 3IATLAS did. And for the first time, people began to feel that cold electric fear, the kind that crawls up your spine when something familiar suddenly behaves like something alive. The question came quietly, almost too quietly to hear. Who's keeping time out there? Because if nature wasn't doing it, something else was. More data poured in. More telescopes locked onto the object. The pulse never drifted, never wavered. Every 12 seconds. A rise, a flash, a breath. Some scientists tried to dismiss it. Maybe the rotation of the object aligned just right. Maybe sunlight was hitting a reflective patch of ice, like a spinning mirror. Those theories lasted about a day, because new readings showed something impossible. The pulse didn't match the rotation rate. It didn't match sunlight angles. It didn't match thermal changes. It didn't match anything. It just kept going. Perfect timing, perfect rhythm. Like a lighthouse built for the dark. One astrophysicist in Berlin wrote in her notes, "This is intentional cadence. It's too precise to be random." She didn't share that with the public. Not yet. The world wasn't ready for words like intentional or designed. Still, everyone felt the weight of it. Every 12 seconds, humanity was being tapped on the shoulder by something drifting through our system. Something that didn't care about our rules or our understanding. A quiet pattern, a steady signal. 12 seconds. Scientists ran tests to break the pattern apart. Fourier transforms, signal isolations, noise-cleaning filters. The deeper they looked, the clearer the pulse became. It wasn't just brightening. It had structure. Each pulse carried a tiny shift, a small but consistent set of changes in its shape. Like each beat wasn't just light, but information. Some saw it as too far-fetched. Others started to panic. Because nature doesn't send information in timed flashes, machines do. And that was the word no one wanted to say out loud. Machine. Not yet, not officially, but it hung in the air like smoke. The pulse spread through the global science community like a secret too heavy to hide. Students stared at the data and felt chills. Professionals with decades of experience went silent. A comet had no reason to pulse, no reason to keep time, no reason to behave like a beacon drifting between worlds. But 3I/ATLAS wasn't behaving like a comet. It was behaving like something watching or waiting. A researcher in Hawaii made a joke during a late shift, the kind of joke you make to break tension, even when you're scared. Maybe it's knocking. No one laughed, because deep down they wondered the same thing. What if this object wasn't passing through? What if it was signaling? What if every 12 seconds it was counting down to something? Still, the scientific world tried to stay calm. Everything had to be tested, verified, repeated. But as the nights passed, the pulse only grew clearer, more organized, more undeniable. And then something even stranger happened. The pulse changed. Not wildly, not enough for chaos, just enough for intent. Every 100 pulses, the shape of the flash shifted by a fraction. It was small, so small it barely registered. But it meant one thing. The rhythm wasn't just repeating, it was communicating, because anything that changes on a cycle, anything that swaps patterns in perfect timing, isn't acting alone. People began to wonder, if this was a message, who was it for? Us? Something farther away? Something coming after it? Or was it simply broadcasting, like a lost traveler sending a beacon home? The world didn't know. But they did know this. The pulse wasn't random, it wasn't natural, and it wasn't slowing. 3I/ATLAS continued drifting deeper into the inner solar system. The beat followed it like a ghost, 12 seconds apart, as steady as a heartbeat in the dark. Scientists sat in dim rooms with cold coffee and tired eyes, watching the flashes play out on screens, each one whispering the same quiet question. What kind of object keeps perfect time while crossing millions of miles of space? Because dust can't. Ice can't. Rocks can't. But machines can. And somewhere in that realization, fear turned into fascination. If this was a message, what did it mean? If this was a warning, who was it for? And if this was a beacon, then where was the sender? The world leaned closer to the mystery, because the rhythm wasn't slowing. It wasn't drifting. It was growing. And the next chapter would reveal a truth, even stranger, that the pulse wasn't the only thing coming alive. There are moments in science when the universe feels predictable. Moments when numbers behave the way they should. When heat rises. When cold fades. When the laws of physics hold everything together like a quiet promise. But then there are moments when that promise breaks, and this was one of them. As 3I/ATLAS began turning toward the sun, everyone expected the same simple thing to happen. Heat, a slow warming, a gentle rise in temperature. The same natural reaction every comet has when it gets close to the star that rules us all. But instead, something impossible happened. The object cooled. Not a little, not in a messy or random way, but in a sharp, sudden drop, as if it had flinched away from the sun. Across control rooms around the world, alarms went off. Scientists leaned closer to their screens, blinking in confusion. Cooling was the last thing the object should do. The sun doesn't cool things. It burns them. Yet 3I/ATLAS acted like it was stepping into shadow, even when it was surrounded by light. For the first few minutes, no one said a word. There was only quiet disbelief, the kind that tightens your chest because the universe is breaking its rules right in front of you. Thermal sensors continued to stream in new data, each reading stranger than the one before. The temperature didn't just drop, it dropped in steps. Clean steps, even steps. Almost geometric in shape. 5 degrees. Pause. 5 more. Pause. Again. 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 Like someone was turning a dial. One researcher in California whispered, "It's regulating itself." But that made no sense. A comet can't regulate anything. It doesn't think. It doesn't adjust. It just melts under heat, like everything else in space. Yet this object behaved like it was shielding itself, defending itself, protecting something deep inside. Hours later, when the temperature finally began to rise again, the rise wasn't natural either. It didn't curve softly. It didn't follow the physics every model predicted. It rose in the exact same geometric steps. 5 degrees. Pause. 5 more. Pause. The readings looked less like a comet and more like an engine starting up, a machine running checks, a system responding to heat in ways no natural body ever could. Teams across the world tried to build an explanation. Maybe it had strange materials in its core. Maybe it wasn't a comet at all. Maybe it was just a rare type of object we'd never seen before. But then someone noticed something chilling. The cooling and heating weren't just steps. They were mirrored. The exact same pattern. Forward and backward. Rise and fall. Perfect symmetry. Nature is beautiful. But it isn't symmetrical like that. Not with heat. Not with energy. Not with something being blasted by the sun. This wasn't beauty. This was precision. And precision feels like design. As the hours passed, scientists started digging deeper into the data. Some looked for hidden cycles. Others searched for exotic materials or chemical reactions. But one thing kept bothering them: the timing. The temperature shifts happened on a schedule, a rhythm. Every step lasted the same number of seconds. Every pause was identical, just like the pulses in the light curve, just like the 12-second rhythm from before. 2 impossible patterns, 2 machine-like behaviors, both coming from the same visitor. A quiet fear settled into every lab that night. The kind of fear that comes when unrelated mysteries start lining up too perfectly. A comet with a heartbeat. A comet that keeps time. And now, a comet that regulates its own temperature like a living system. It didn't feel random anymore. It felt like preparation. One researcher in Japan said it out loud, even though she regretted it a second later. It's adjusting, like it's getting ready for something. Her voice cracked in the recording, not because she believed in aliens or machines or anything that dramatic, but because the numbers left no room for comfort. The cooling wasn't defensive. The heating wasn't passive. Each change felt deliberate, controlled, measured, like someone or something was running a test. When the news reached a private meeting of astrophysicists in Europe, the room went silent. No one wanted to be the first to speak. Every set of eyes stared at the same plotted graph. A staircase of heat, perfectly spaced, perfectly timed. Someone finally broke the silence. "Machines do this," he said quietly. "It's how systems stabilize themselves before pressure changes." No one disagreed. No one dared. Because if that was true, if an object from another star system was cooling and heating itself with precision, then humanity wasn't watching a comet. It was watching something built, something engineered, something arriving with purpose. But the question haunted everyone. Was it preparing to survive perihelion, or preparing for what comes after? By the next morning, the thermal pattern repeated. Same steps, same pauses, same mirrored rise and fall. It was undeniable now. 3I/Atlas was acting alive. Maybe not alive in the way we think of life, not flesh, not bone, but alive in the way a ship is alive, in the way a device breathes through pumps, circuits, stabilizers, and heat shields. The temperature climbed again, then stopped. Every sensor froze at the same moment. A plateau, a perfect line, no drift, no noise, almost as if the object had reached its final setting, its final mode, its final ready state. Scientists stared at the graph with a kind of awe and fear, because comets don't choose temperatures. They don't settle into clean plateaus, but machines do, before they begin their real function, before they activate. As the object moved deeper into sunlight, its temperature held perfectly steady, a line so straight it felt impossible, like a creature unbothered by the heat, like something built for the fire, like something waking up. By the end of the day, everyone realized the same truth. This wasn't physics anymore. This was behavior, intentional, repeated, measured. And as 3I/Atlas continued on its path toward the sun, the world leaned in, heart pounding, wondering what would come next. Because if the object was adjusting itself like a machine, then maybe it wasn't just passing through. Maybe it was preparing. And in the next chapter, humanity would finally see something no one expected. A surface that wasn't natural at all. Sometimes the truth doesn't hide in darkness. Sometimes it hides in light. Or in this case, in the way something reflects it. When the first radar scans of 3I/Atlas came in, no one expected anything special. Just rough textures, random ice patches, a normal, uneven surface like every comet we've ever studied. But what they found wasn't random, and it wasn't normal. A small research team in Spain noticed it first, a bright spike in reflectivity, a spot so sharp, so intense it didn't fit with anything natural. Not dust, not ice, not rock. It reflected radar waves almost like metal. At first, the team thought it was an instrument error. Maybe a calibration issue, maybe interference from Earth's atmosphere. But when they ran the scan again, the same patch lit up, same position, same brightness. And then another patch appeared, then another and another. Each one was small, precise, too bright for comfort. They formed a pattern across the surface, not scattered, not chaotic, but arranged like pieces of a map, or the fragments of a larger picture. Across the world, scientists leaned closer to their screens, zoomed in, reconstructed the scans. And slowly, something eerie took shape. The bright patches connected to form a repeating shape, a long, curved structure, almost like a symbol stretched across the object's body. It wasn't perfectly straight, but it repeated. Every rotation, every cycle, every pass of the object through the radar beam, the shape stayed aligned with its movement, like it wanted to be seen. That was the part that scared people the most. It felt intentional. Natural objects don't place bright spots in patterns. They don't repeat symbols. They don't align reflectivity with rotation. But 3I/Atlas did. And in some control rooms, the mood shifted from curiosity to dread. A junior analyst in France whispered, "It looks like it's marked." Another researcher in Canada asked, "Marked by what?" But the real question, the one nobody wanted to say, hung heavy in the air. Marked for whom? The reflectivity pattern rotated in perfect sync with the object's spin. It didn't drift. It didn't break apart. It didn't fade. Sometimes it even brightened at just the right moment, catching the radar like it was signaling back. And the more scientists watched it, the more it felt like the object was presenting itself. Imagine something drifting through space, turning its body in just the right way, making sure a symbol stays visible to whoever might be watching. That was the feeling 3I/Atlas gave off. It wasn't hiding. It was showing something. But what? As more scans came in from NASA, ESA, and Japan's JAXA observatory, the picture became even clearer. Not only were the reflective patches arranged, their angles matched. Each patch pointed toward a specific direction in space. Not toward the sun, not toward Earth, but somewhere else, somewhere beyond both. At first glance, it looked like nothing, just random coordinates. But when plotted in 3 dimensions, the patches aligned into a strange geometric arc, almost like a compass pointing toward a destination too far for us to understand. A destination the object might be moving toward or returning from. The idea sent chills down the spines of every scientist who saw it, because comets don't carry symbols. They don't point in directions. They don't put messages on their surface. But artifacts do, machines do, ships do. And suddenly, the reflectivity pattern didn't feel like nature anymore. It felt like language. People debated what it meant. Was it a destination? A warning? A name? Some kind of identification plate? Like those we put on satellites. For the first time, the scientific community whispered about something they had avoided since the first light curve glitch. What if 3I/Atlas wasn't the name of an object, but the name of something sent? International teams ran high-resolution modeling to reconstruct the surface. And when they finally rendered a full image, everyone in the room went silent. The bright patches formed an almost organic curve, smooth, looping, precise. Not mathematical enough to be human-designed, but too perfect to be random. A symbol etched across the body of an interstellar visitor. Some compared it to a spiral. Others saw it as a wave. A few even thought it looked like an eye. A long, stretched eye, staring outward into the void. But that wasn't the strangest part. The symbol wasn't flat. It had depth. Like trenches, or plates, or panels meant to catch the radar and throw it back in specific patterns. The patches weren't just reflective. They were sculpted, like a message carved in metal. And then came the moment that changed everything. During a live radar pass from a station in Hawaii, the reflective symbol brightened, suddenly, sharply, just as the object completed a rotation. It was timed, perfectly timed. As if 3I/Atlas knew that someone was watching at that exact moment. The scientists on duty stared in shock. Some froze, others whispered. A few stepped away from their screens completely. Because the brightening wasn't natural. It wasn't caused by sunlight. It wasn't caused by temperature. It happened only when the radar beam hit the symbol. Not a second before, not a second after. A response, a blink, a sign. And it left them with a question that felt heavier than anything they'd asked so far. Who was the symbol meant for? Was it meant for us? Or was it meant for something else out there? Something that had yet to arrive? Because this wasn't a comet, this wasn't a rock. This was a traveler, a visitor carrying a mark meant to be found. And as the object drifted closer to the sun, its strange symbol rotated like a beacon. A quiet reminder that we weren't just observing it. It was observing us too. In the next chapter, humanity would discover that the silence wasn't silence at all, and that 3I/Atlas was listening. Sometimes silence is louder than sound. Sometimes it hits you like a cold wind, making you step back and wonder what just stopped and why. That's exactly what happened when 3I/Atlas reached the ecliptic plane. Now, the ecliptic is nothing special on its own. It's just the invisible flat sheet where all the planets orbit, a kind of cosmic highway that everything in our solar system follows. Comets cross it all the time. Asteroids glide through it without anyone noticing. But when this object crossed it, the universe held its breath. And so did we. For days, radio telescopes had been recording faint emissions from 3I/Atlas. Not signals, not messages, just the soft static of a natural object moving through charged particles. Everything was normal, predictable, steady. But then the object reached the ecliptic, and the radios went quiet. Not slowly, not fading, not gradually dimming the way natural static falls away. They stopped. All at once. 3 minutes of complete silence. Every station around the world, from the giant dishes in New Mexico to the quiet observatories in Japan, reported the exact same thing. A sudden drop, a flat line, a dead frequency. It was as if 3I/Atlas shut itself off. One researcher described it as watching a heartbeat stop in the middle of a pulse. Another called it a quiet you can feel, because this wasn't just silence. It was coordinated silence, intentional, perfectly timed. The world didn't know yet that those 3 minutes would become one of the biggest mysteries of the entire encounter. In control rooms across continents, scientists stared at empty graphs, listening to a void that shouldn't have existed. Some tried to reboot equipment. Some checked cables. Some ran diagnostics so fast their screens blurred. But every check came back clean. Nothing was broken. Nothing was glitching. The object had simply stopped talking, stopped humming, stopped interacting with anything. And that raised a terrifying thought. Was it listening? Because the timing wasn't random. Crossing the ecliptic is like crossing a boundary. The moment an object moves from the edge of the system into the ancient plane of the planets. It's where the solar system becomes more organized, more structured, more predictable. The place where everything important happens. So why would 3I/Atlas go silent there? People in the scientific community whispered possibilities. Maybe the object detected the shift. Maybe it sensed something. Maybe it recognized the plane the same way a traveler recognizes a border. Or maybe it activated something new. Deep scans of the silence revealed something chilling. Even though radio emissions stopped, the object's motion didn't change. It didn't slow. It didn't drift. It held its path with perfect stability, almost too perfect, like a machine entering a specific state. But the strangest part came right after. Exactly 3 minutes later, almost to the second, the radio emissions returned. Not slowly, not warming back up. They returned in a single, sharp spike, as if something had been switched back on. That spike wasn't random noise. It had structure, rhythm, a strange stutter inside the frequency that scientists had never seen before. Some said it almost looked like an all-clear signal. Others thought it resembled a system rebooting, but no one agreed on what it truly meant. Only one thing was certain. The silence wasn't natural. Something chose it. Something timed it. Something controlled it. And that fact alone sent waves of fear and fascination through every lab on Earth. Because natural objects don't go quiet in unison. They don't pause all radio emissions like a machine going into sleep mode. They don't stop for 3 minutes and then turn back on like nothing happened. But machines do. Systems do. Technology does. And that idea, that terrifying idea, made some scientists lose sleep for nights. There was another detail too, one most people outside the field never heard about. During those 3 minutes of silence, something else changed. The reflective patches on the object, the ones forming that strange symbol, darkened slightly, almost like they were absorbing more light than they were bouncing back, as if they were closing. Imagine a creature blinking. Imagine shutters sliding shut. Imagine panels sealing themselves before something important happens, and then opening again once the moment passed. That's what it looked like. A response, a transformation, a shift. When the signal returned, the reflectivity went back to normal. The patches brightened again. The symbol lit up, as if the object wanted to be seen once more. As if the silence had been a private moment. A moment where it didn't want to be observed. A moment where it prepared or listened. Days later, when scientists replayed the recordings, they noticed something even more unsettling. Just before the silence began, less than a second before it, there was a tiny spike in frequency, a microburst, barely detectable, almost hidden, like the object sent out a quick ping, a call, a whisper into the dark. And then it went quiet. What was it calling? What was it waiting to hear? What answered back, if anything? No. One knows. But the timing left experts breathless, because that microburst pointed not toward the sun, not toward Earth, but toward a specific region, far beyond the planets, a direction matching the orientation of the reflective symbol on its surface, as if everything was connected, the pulse, the temperature shifts, the strange symbol, and now this silence. 3 minutes that felt like an eternity. 3 minutes that told us we weren't watching a comet. We were watching behavior, intention, purpose. And as the object left the ecliptic plane and continued its journey toward the sun, scientists realized something chilling. If it could turn itself off, what else could it do? Because the next chapter would reveal that the silence wasn't silence at all. It was cover. A cover hiding a signal that wasn't meant to be found. Sometimes the truth doesn't show up in what we hear, but in what hides beneath it. Buried, faint, almost afraid to be found. That's what happened after the silence. When 3I/Atlas crossed the ecliptic plane and every radio telescope on Earth went quiet, the world felt the weight of those 3 minutes. 3 minutes where the object turned itself off, or turned itself into something else. But the moment the radios came back online, something strange happened. A spike, a burst, a crack in the static, like lightning tearing through a night sky. It lasted less than a heartbeat, but it didn't feel random. It felt placed. Analysts caught it on multiple stations: Chile, Germany, South Africa, Hawaii. the same spike, the same shape, the same impossible timing. At first, they thought it was just a glitch from the sudden reactivation of instruments. That's what the human mind wants. Simple answers, clean explanations. But then, one analyst did something different. He slowed down the recording. Not much. Just enough to stretch that thin band of static into something you could actually see. And that's when they found it. A pattern. A faint hidden structure, woven into the noise like a whisper, pressed into sand. The static wasn't static. The randomness wasn't random. There was something encoded inside it. Something faint. Something almost too soft to notice. But once you saw it, you couldn't unsee it. It was a signal. The room froze. Then panic spread like a cold tide. They ran the data again, filtered it, cleaned it, checked for atmospheric interference, equipment faults, satellite crossings, every possible thing that could cause a false positive. But no matter how many layers they peeled back, the signal stayed there, quiet, steady, impossible. It didn't match any natural radio signature the universe makes. Not pulsars, not solar storms, not cosmic rays. It didn't match human technology either. No satellite ping, no military frequency, no Earth-based transmission. It was other. But the more they studied it, the stranger it became. The signal had structure, not like language, not like math, but like intention. You could see rises and falls, pauses, repeating shapes. It was almost like a breath, a whisper, or a knock. Analysts began to argue. Some said it was a message. Others said it was a malfunction inside the object, like a device powering back on. But one thing united every expert, every room, every sleepless mind that replayed the recording again and again. The signal wasn't supposed to exist, because natural objects don't hide information in static. They don't send structured pulses buried under noise. They don't compress patterns into microseconds like a code waiting to be unlocked. But devices do, machines do, transmissions do. And suddenly, the world was staring at a possibility too dangerous to say out loud. A message. But from whom and for who? Late that night, a small team in Japan enhanced the signal even further, and that's when they uncovered something chilling. The pattern repeated, not like words, not like sentences, but like coordinates. A rising slope, a sharp drop, a mirrored echo, then again, and again, and again. It wasn't random. It wasn't mathematical noise. It was direction, a vector, a path, and it pointed, not toward the sun, not toward Earth, but toward the same region of space, the reflectivity symbol aligned with 3 anomalies. One direction. Something out there was connected to 3IATLAS, or calling it. One analyst pointed out something even more unsettling. The signal didn't just appear when the radios came back. It appeared because the radios came back, like the object was waiting, watching, listening. What if the silence wasn't an accident? What if those 3 minutes were a doorway, a moment where the object listened for something before choosing to reply? And if that's true, reply to what? Some scientists believe the object sent a confirmation ping, like a device saying, "I made it." Others thought it was a distress signal, a cry into the void, reaching for something that might not exist anymore. But a smaller group, the ones who studied interstellar signals their whole lives, said something even darker. This looks like a warning encoded so faintly that only a species advanced enough to build giant radio arrays would hear it. A warning that rides on silence. A warning hidden inside static, so no one else finds it. A warning meant for a world that is only just beginning to understand what's coming. Still, nothing was confirmed. There were no translations. No Rosetta Stone. No clear meaning. Just a quiet understanding that weighed on everyone. The signal wasn't accidental. It was placed, delivered, embedded. And whatever it wasn't meant to comfort. The more the world listened, the colder the truth felt, because signals like this aren't sent by wanderers. They're sent by travelers, by machines, by things that have purpose. And if this was a message, if this was a warning, what was the object warning us about? The scientists studying the data didn't say that part out loud. Not yet, not in the open, but they felt it. Like a shadow leaning over their shoulder, because every great mystery has a beginning. Every signal has a source, and every warning comes from something capable of danger. As 3I/Atlas continued deeper into the inner solar system, the signal faded, not because it weakened, but because it ended, like a sentence with no explanation, like a door closing, and the world was left with a single, unshakable thought, one that echoed through observatories and sleepless minds everywhere. If that was a message, was it meant for us? Or was it meant for something that hasn't arrived yet? In the next chapter, those fears grow even stronger as our models begin to break one by one. There are moments in science when the numbers stop being numbers and start becoming something else. A message, a warning, a quiet voice whispering, "You don't understand me." That's exactly what happened when scientists tried to model 3I/Atlas. After the strange light pulses, after the geometric thermal shifts, after the reflective symbols, after the sudden silence near the ecliptic plane, the world needed answers. So researchers did what they always do when faced with the unknown. They built models, dozens of them, high-powered simulations, trajectories, thermal curves, rotational dynamics, chemical predictions, everything you can imagine. Some ran on university supercomputers, some ran in government labs, some ran in quiet observatories where one or two exhausted scientists stayed awake until sunrise. All of them chased the same goal, to understand what 3I/Atlas actually was. But the models didn't just fail, they broke themselves. The first signs were small, a simulation freezing at the exact moment the temperature pattern appeared, another spitting out numbers that shot off into infinity, a third reversing its own timeline as if it couldn't handle the data it was given. At first, everyone blamed coding errors, bad inputs, corrupted files, computers overheating. But then it started happening everywhere. Different labs, different countries, different systems, same outcome. Every model lasted a few hours and then collapsed. Not randomly, not messily. Collapsed in the same places the object behaved strangely in real life. The thermal models broke when they reached the geometric steps. The rotational models froze when they hit the reflectivity symbol. Trajectory models snapped when they crossed the ecliptic plane, just like the object itself went silent. It was as if the object's real behavior infected the simulations. A researcher in Germany said, "It's like trying to predict something that refuses to be predicted." Another in the US whispered, "It almost feels like the object knows we're trying to understand it, and it's pushing back. But the strangest failures came from the most advanced simulations, the ones designed to track gravity, heat, light pressure, and interstellar dust all at once. Those simulations didn't just fail, they looped. They created perfect circles inside their own datasets, cycling the same few seconds over and over and over, like a record stuck on a haunting note. One programmer spent 8 hours watching the same 2 seconds repeat 100,000 times before the system finally crashed. The logs showed something impossible. The simulation kept rewriting its own equations. Not the outcomes, not the visuals, the equations. Like something inside the model was trying to change the rules. Now, computers don't rewrite equations. They don't modify physics. They don't shift math just because reality doesn't fit. That's what makes simulation stable, predictable, safe. But this object, this visitor drifting through our solar system, it didn't fit the rules. And when scientists tried to force it to, the rules bent. One of the oldest researchers in the field made a quiet note in his journal, a line that later leaked online and shook people to their core. Whatever this object is, it resists being understood. He wasn't being poetic. He meant it literally. Because the deeper simulations tried to go, the more the data twisted, the more predictions fell apart, the more the object's future path refused to stay put. At one point, the same model predicted the object would hit Venus, then that it would hit Mercury, then that it would leave the solar system, then that it would swing back toward Earth. 4 different outcomes in less than 30 minutes. It wasn't the model that was broken, it was reality, or at least reality as we understood it. Some scientists began whispering theories they never would have dared to speak aloud, even a month earlier. What if the object wasn't following gravity the way normal things do? What if it wasn't responding to heat the way natural objects respond? What if it wasn't reacting to physics? What if it was choosing? Choosing how much to reflect, choosing when to cool, choosing when to talk, choosing when to go silent, and choosing how or whether to let itself be predicted. A small team in Japan ran one last experiment. They built a model without human rules, without fixed equations, without assumptions. A model that could adapt, learn, evolve. And for a moment, just a moment, it worked. The simulation lasted longer than any before it. Hours stretched into almost a full day. Data flowed smoothly. The object's path made sense. Its strange behaviors lined up perfectly. But then something happened that no one was prepared for. The simulation began calculating the object's internal structure, not because they asked it to, not because it was programmed to, it just did. As if the model suddenly wanted to know how the object worked. And then the simulation shut down, not crashed, not froze, shut down, like someone pressed a power switch, like something inside the model had reached a part of the truth it wasn't supposed to touch. The system never turned on again, not even after repairs, not even after the hardware was replaced. It was dead. And to some of the scientists involved, that didn't feel like coincidence. It felt like a boundary, a line, a quiet message. Do not look deeper. By now, the world had stopped pretending 3IATLAS was predictable. It wasn't following the rules. It wasn't following the models. It wasn't following the physics we built our entire understanding of space on. It was something else, something freer, something unbound. As one astronomer put it, it's like the object is rewriting reality as it moves. And if that was true, then the next question was even more terrifying. What is it rewriting reality toward? Because in the next chapter, scientists will finally accept the theory they'd been avoiding from the very beginning, that maybe, just maybe, this thing isn't natural at all. There are moments in human history when a quiet truth sits in the room, unspoken, heavy, waiting for someone brave enough to finally acknowledge it. And for the scientists studying 3I/Atlas, that moment came sooner than anyone expected. It didn't happen with a big announcement. It didn't happen during a conference or inside some government briefing room. It happened late at night, in private messages, in whispered conversations, in the exhausted breaths of people who had watched the impossible unfold day after day. After the pulses, after the thermal patterns, after the reflectivity symbols, after the silence, after the signal hidden inside the noise, after the simulations that broke themselves. The patterns weren't random anymore. They weren't natural. They weren't the behavior of rock and dust drifting through space. And finally, a small group of scientists admitted what every instinct had been screaming for weeks. This is a machine, not a comet, not a fragment from a dying star, not a piece of frozen debris left wandering across cosmic time. A machine, something controlled, something built, something with purpose. At first, even saying the word felt like stepping off a cliff, like crossing a line science wasn't supposed to cross. But once the idea left their mouths, they couldn't take it back. And they couldn't ignore how painfully well it fit the data. Machines pulse with rhythm. Machines regulate temperature. Machines carry symbols and markings. Machines send coded signals. Machines enter silent modes. Machines break simulations because simulations assume nature, not intention. 3I/Atlas wasn't behaving like nature. It was behaving like intention. One astrophysicist in France wrote the first unofficial note on it. We are no longer modeling physics. We're modeling decision-making. Another researcher in Canada described it even more simply. It feels piloted. But if this thing was a machine, a vessel, a craft, then the real mystery wasn't what it was. The real mystery was who made it and why it was here. The first theory was hopeful, almost naive. Maybe it was an ancient probe, like the ones humans send out to the edges of the solar system. Something built billions of years ago by a vanished civilization, a relic drifting through the dark. But that theory shattered instantly. The object wasn't drifting. It was adjusting, reacting, responding. Ancient relics don't regulate heat with precision. They don't emit timed pulses. They don't silence themselves for exactly 3 minutes when crossing an orbital plane. This wasn't dead technology. It was active, possibly aware. And that realization changed the mood in every room where the data was being studied. Gone was the excitement. Gone was the curiosity. In its place came something deeper, a weight, a pressure, a cold understanding that no one wanted to face. If this object was controlled, then someone controlled it, or something. Across private group chats and encrypted calls, the scientists discussed the same question over and over. Where did it come from? Some pointed toward the direction of its arrival, a region with no known stars close enough to launch anything here. Others suggested a civilization so advanced it could build machines that last millions of years. A few whispered chills no one dared to speak publicly. What if it didn't come from where we think? What if its arrival path was engineered? What if the object didn't travel across time and space? What if it was placed? But the darkest theory of all came from the smallest group, the ones who studied patterns too clean to ignore. They believed the object wasn't exploring. It wasn't observing. It wasn't searching. It was following instructions. Like a drone, like a scout, like something sent ahead of something larger. One scientist summarized it in a single line that spread like wildfire through private scientific circles. We are not watching a visitor. We are watching the first piece of something bigger. But even that wasn't the part that frightened the researchers the most. The part that truly haunted them was the purpose. Because machines are built for a reason. They have tasks. They complete missions. If 3IATLAS was a machine, then it wasn't here by accident. It was here because someone or something wanted it to be. So what was it doing? Some believed it was mapping the solar system. Others thought it was gathering signals, listening for intelligent life. A few suggested it was storing data, cataloging us, the way we study planets and animals. But one theory began to rise above the rest, not because it was comforting, but because it fit the facts. The machine was preparing. Every movement, every adjustment, every temperature shift, every pulse, every silence. It all felt like setup, calibration, activation. Like the object wasn't searching for something. It was waiting for something. Waiting for alignment, waiting for position, waiting for a moment that had been calculated long before humans ever built telescopes. And as the object drifted deeper into the inner solar system, the fear became impossible to ignore. If this machine wasn't here by accident, if it wasn't lost, if it wasn't relic, then what was it here to do? And what happens when it finally does it? Because the next chapter would bring a moment no one saw coming. The moment the machine finally awakens. There are moments in life when everything you thought you knew breaks in front of you. Moments when the world feels suddenly smaller, quieter, more fragile. That moment arrived the day 3I/Atlas swung around the sun. For weeks, the object had been building toward this. Every anomaly, every pulse, every shift, every silence. It all led here, to the moment it reached Perihelion, the closest point to the sun's burning face. Astronomers expected chaos, heat, gas jets, fragmentation. That's how normal comets behave. They flare wildly as they get close, shedding ice and glowing bright. But 3I/Atlas wasn't normal. And when it rounded the sun, what happened next didn't look like destruction. It looked like awakening. It began subtly at first, small flashes of light flickering across the object's surface. Not sunlight, not reflection. Something else. Something internal. Then the flashes grew brighter, sharper, more rhythmic. They formed a pattern, a rising sequence, each flare more intense than the last. Scientists watched in stunned silence as the object lit up like a heartbeat speeding up. 1, 2, 3, 4, each pulse climbing in brightness, stacking upward, as if the object were powering on. No one spoke. People leaned over their screens, frozen in disbelief. This wasn't random light scatter. This wasn't heat boil off. This wasn't nature. It was a sequence, a build-up, a deliberate rise. Exactly the kind of pattern machines make right before activation. A small team in Switzerland was the first to say it aloud. It's turning on. And even they didn't believe their own voices. Because how do you look at something older than your species, traveling from another star, and say it's waking up. Yet there it was, a rising crescendo of flares, carving symbols of light into the blackness of space. Every telescope pointed at the object saw the same thing, a sequence too structured to be random, too steady to be chaotic, too perfect to be natural. The flares weren't just brightening, they were aligning. Each one illuminated a different part of the symbol engraved on the object's surface. First, the curve, then the arc, then the long reflective line that traced the object's side like a blade of light. It was as if the symbol itself was being lit on purpose, as if the object were saying, "Look at this." The entire scientific world held its breath, because for the first time, the symbol wasn't just visible, it was active. And then things got stranger. As the object completed its turn around the sun, it released a burst of flares so bright they outshined the background stars. These weren't random flashes. They stretched outward in a branching formation, almost like spokes radiating in every direction. But one direction was brighter than all the others: Earth. Every flare pointing our way was stronger, sharper, more defined, like a spotlight, like a signal, like an eye-opening and locking onto us. No one wanted to say what they felt, because saying it made it real. The object wasn't just active, it was aware. Some scientists whispered that this wasn't activation, it was alignment. A system adjusting its orientation after the gravitational slingshot, like a spacecraft correcting its course. Others believed it was a scanning sequence, mapping targets, searching for signals, identifying intelligent life. But the darkest interpretation came from the teams studying the timing. The rising flares weren't random intervals. They followed the same rhythm as the early light pulses, 12 seconds apart. The object hadn't abandoned its beat, it had amplified it. The heartbeat was stronger, now louder, bolder, like a machine coming out of sleep and into full power. With every pulse, the object's path shifted by microscopic amounts, not enough to alter its orbit, but enough to prove that something inside was firing. New engines, stabilizers, communication arrays. No one knew. But whatever it wasn't passive. And then came the moment that changed everything. As the last flare burst outward, a thin, impossibly straight beam shot off the object's surface, not bright enough to be a weapon, not wide enough to be an emission cone. Just a line, a thread, a direction. It pointed straight toward Earth and held there for 7 full seconds. No jitter, no curve, no drift, a perfect line. Then it vanished. Some described it as a scan, others as a signal. A few, in shaking voices, called it a lock-on. But whatever it was, every person watching felt the same thing in their chest. A sinking sensation, a quiet realization. Earth was noticed. For the first time, the object wasn't just passing through. It was interacting, choosing us, acknowledging us, and maybe measuring us. The flares faded slowly. The object's glow softened. The symbol dimmed, as if it had completed its cycle. But humanity knew this wasn't the end of anything. It was the beginning of a stage no one was prepared for. A stage where the machine was fully awake and fully aware of our presence. And as 3I/Atlas left Perihelion and began drifting back toward the outer system, its entire body shivered with tiny bursts of light, like a creature stretching its limbs. The world watched in silence, hearts racing, minds spinning. Because if this was the awakening, then what came next? in the next chapter, the object reveals something even stranger. Not what it is, but where it's pointing. A message etched in light with a destination far beyond anything we've ever imagined. Sometimes the universe hides its secrets in darkness, but sometimes it hides them in light, not in brightness, not in color, but in patterns, in the tiny rhythms that repeat again and again until someone finally realizes, this isn't noise, this is information. And that's exactly what scientists discovered when they studied the flares from 3I/Atlas. After the awakening sequence, after the object lit itself like a rising heartbeat, the world expected chaos. Maybe another flare burst, maybe a beam, maybe something violent. They didn't expect math, but math came anyway. Quietly, patiently, hidden in the cadence of every pulse of light. It began with a small team in Finland, experts in photometric data. They slowed the flare sequence down frame by frame, pulse by pulse. And that's when the pattern emerged. The flares weren't random. They had spacing, ratios, repeating intervals that matched a sequence no natural object produces on its own. Prime numbers. Light bursts appearing in intervals of 2, then 3, then 5, then 7, over and over. A prime sequence written in light. It was like the object was speaking the simplest language that any intelligent species, anywhere, would understand. Prime numbers don't occur that cleanly in nature. Not in rhythms, not in pulses, not in timed eruptions. This wasn't chaos. It was communication. But the scientists didn't stop there. They shifted the data onto a graph, turned the light pulses, from brightness into numbers, from numbers into coordinates. And that's when the world changed, because the coordinates didn't form a spiral. They didn't form a curve. They didn't form anything familiar in our solar system. They formed a shape we'd never seen before. A long, stretched sequence pointing toward a region of space far beyond Neptune, far beyond the Kuiper Belt. Far beyond the Kuiper Belt had come from. It wasn't a route to the sun. It was a route away from it. A map, not of where the object was headed, but where something else was. A distant point, cold, dark, empty on our star charts. At least, that's what we thought. When the data was overlaid onto deep space scans from the last 20 years, the coordinates aligned with a faint region of dust and infrared heat signatures, the kind you'd expect from something hidden, something quiet, something waiting. The object had given us directions. But directions to what? Some believed it was pointing home, to the place where the machine had been built. A birthplace, a forge, a civilization far older than ours. Others thought it was pointing toward another machine, a sister craft, a receiver, a beacon waiting in the dark. But a smaller group, the ones who saw the pattern first, began to fear something deeper. What if the object wasn't pointing to a home? What if it was pointing to a destination? Not where it came from, where it wanted to go. Like a soldier marking coordinates, like a probe calling out to something far away. I made it. I'm in position. Now you come. The thought made people sick. Because the map wasn't just directional, it was instructional. The prime sequence wasn't just a signature, it was a decoding key. Follow the numbers, follow the angles, follow the pulses, and you get a path. A path that curved around dead stars, beyond the gravitational reach of our sun, through a darkness so untouched that no human telescope had ever mapped it clearly. A path that ended in a silence so deep it felt intentional. When the Finnish team published their private findings to a small encrypted board, one scientist replied with a single sentence: "Why would something enter our sun, only to show us how to leave it?" That question hit everyone like a cold wave. Because if the map pointed outward, if the coordinates led away, that meant the object wasn't here for us. It wasn't here to study us. It wasn't here to learn. It was here to tell us something else. Something that frightened every person who ran the numbers. The map ended exactly where the object's early signals had been oriented. Exactly where the reflectivity patches had pointed. Exactly where the silent microburst before the ecliptic crossing had been aimed. Everything, every anomaly, every flash, every whisper, led to the same place. A place far beyond our reach. A place older than our species. A place the object wanted someone to notice. So the world asked, is it calling out or calling something in? Was this a map to safety or a map to danger? A warning or an invitation? Because a machine does not travel billions of miles to draw a map in light unless the message matters. Unless it was sent, or summoned, or instructed. And that realization left scientists shaken. What if the object wasn't a messenger? What if it was a key unlocking a direction, a path, a destination, something waiting in the dark, something that built it, or sent it, or expected it, and the idea that filled every room with that cold, heavy silence. What if the thing waiting out there is still listening? As 3I/Atlas drifted farther from the sun, its flares softened, its symbols dimmed, its pulses quieted. Like the machine had finished its message, finished its purpose, finished its map. But one last question hung over humanity like a shadow. If the map wasn't meant for us, then who was it meant for? And in the next chapter, that question becomes even more terrifying as 3I/Atlas sends out its final, sharpest, most haunting signal yet, the last observation before it vanishes. There's a strange feeling that comes at the end of a mystery, a feeling that sits in your chest like a weight you can't lift. It isn't fear, it isn't relief, it's something quieter, something colder, a sense that the universe just showed you something important and then took it away before you could understand it. That's what happened in the final hours of observing 3I/Atlas. By now, the object had passed Perihelion. Its awakening sequence had finished. Its flares had dimmed. Its symbol had faded back into the dark. It was no longer the bright, pulsing presence that had stunned the world days earlier. It was drifting away, a shadow receding into deeper space. And yet, as the object slipped farther and farther and farther from our telescopes, scientists couldn't shake the feeling that something was still coming. They watched anyway, through tired eyes, through flickering screens, through the quiet hum of observatories thousands of miles apart, waiting, listening, hoping for one last clue. And then, almost exactly when the object reached the edge of detectable brightness, it happened. A single pulse, sharp, clean, perfect. A pulse that cut through the static like a blade of light. It was brief, so brief that some instruments almost missed it. But the ones that caught it didn't just record a flash, they recorded a memory, because that pulse was an exact match to the very first anomaly ever seen from the object, the first dip in the light curve, the first sign that something was wrong, the first whisper that started this entire story. It was identical, down to the millisecond, down to the slope, down to the impossible precision. A perfect echo of the moment humanity first noticed that 3I/Atlas was not what it seemed, and that meant one thing. It remembered. Whether it was a craft or a probe or something far stranger, it chose to repeat its first signal as its final one. A beginning and an end bound together in a single flash across the endless dark. In control rooms across the world, people froze. Some gasped, some whispered, some simply stared at the blinking data with their hearts pounding like they were seeing a ghost. Because this wasn't random. It wasn't a mistake. It wasn't nature. This was intentional. A final message, a final mark, a final acknowledgement of everything that had happened. And then, just seconds after that pulse, the object vanished. Not exploded, not broke apart, not slowed down. It simply faded, its brightness dropping below every threshold, slipping into a darkness so deep that no telescope could follow. It was like watching a door close quietly in the middle of space. One moment, it was there. The next, gone. Scientists scrambled to track it again. They increased exposure times, shifted filters, reached for instruments normally reserved for the faintest galaxies. Nothing. 3I/Atlas had disappeared. Some said it was still out there, too dim to see. Some believed it activated a cloaking mechanism. Some even suggested it powered up and accelerated beyond our tracking abilities. But the truth, no one knew. And that ignorance, that silence, that unanswered question made the last pulse feel even heavier. Because now, that pulse wasn't just a signal. It was a conclusion. Or a warning. Across private scientific boards, messages flooded in. Was this event a cycle? Will something else follow it? Did it send instructions to something else? Was the map meant for a second object? Has the real arrival not happened yet? These weren't conspiracy theories. They came from the same people who had spent months watching the object with trained eyes, exhausted minds, and instruments designed to catch the faintest truths of the universe. They weren't panicking, they were preparing, because the final pulse left one haunting possibility. This story wasn't over. Maybe we witnessed a visitor, a lone machine from the cold dark between stars, passing through our system like a traveler between worlds. Or maybe we witnessed the first piece of something larger, something coordinated, something deliberate, something that sends scouts long before it arrives. If the last pulse was a goodbye, it felt almost gentle, a final nod from a machine older than our species. But if it was a warning, then it meant something else entirely. It meant the machine was telling someone, or something, where we are. It meant the flare map wasn't a message for humanity, but a message using humanity. A signal meant to be seen by eyes that are not ours. And that thought hung in the air long after the object vanished, long after the screens went dark, long after the scientists packed up their notes and tried to sleep through something that refused to leave their minds. What did we witness? A visitor passing by? Or a probe sending a beacon home? A machine exploring? Or a machine calling? A traveler? Or a scout? No one knows. Maybe no one will know for years, decades, centuries. But as 3I/Atlas slipped beyond the reach of human technology, one truth lingered in every room where the data had been studied. Something entered our solar system. Something watched us. Something reacted to us. And something left. but not before saying one final thing. A message wrapped in a single pulse, as clean and perfect as the one that started it all. A message that ends the story exactly where it began. A whisper across the void, asking a question that humanity may spend lifetimes trying to answer. Was I the first? And as the darkness swallowed the object whole, the only thing left was the echo of that question, and the unsettling possibility that something else might answer it.